audible to you?
Yeah, sir.
Okay. Okay. So let's go for next level of understanding of rotational symmetry, that is spin. So we have seen all about the uh, angular momentum, and whatever we have seen that it is popularly equivalent to orbital angular momentum. What is meaning of orbital angular momentum? Means if particle is rotated about a particle, about axis, which is not inside this particular particle or body. So obviously we have orbit, the particle is going to orbit about any particular axis, then we can use this angular momentum algebra, such as we have also seen that two different problem that we have one particular particle and one particular axis and particle is rotating in a circle. So we have seen this kind of situation. Now let's try to go for a spinning. Suppose we have one particular ball, a spherical ball, and it can spin about its own axis. So it can spin about its own axis in clockwise direction as well as anti-clockwise direction. And then from analogically, we will try to understand the internal symmetry of a rotation for a particle. And this is known as a spin. Why we are just talking about that this spin character is differently from the angular momentum character, because the result is little bit different. But yes, logic and mathematical argument is exactly same. So first, what is the result? We will discuss from the Stern-Gerlach experiment, and then we will try to understand how we can implement our knowledge of angular momentum algebra to understand all these experimental evidences. So we have earlier also discussed this Stern-Gerlach experiment. We are again going to repeat it, but right now we will just try to analyze what is actually happening. So let's go for Stern-Gerlach experiment. So for a Stern-Gerlach experiment, we have one screen, and this is the magnetic field, and this is inhomogeneous magnetic field. Let's say magnetic field in this direction, and this is, I can say this is nothing but what? Z direction. And here we have one source of electron, and we just heated this electron, and not electron, this is basically silver atom. Actually inside this particular box we have silver atom. We just give the energy of this silver atom, and what we have seen what is going to happen on this particular screen. So what is beautiful part of silver atom, that silver atom have atomic number 47. What is meaning of atomic number 47? Means the outermost orbit have single electron, and all other orbits are completely filled. So outermost orbit is single electron and all other orbit is completely filled. So whatever with the interaction of this magnetic field to the silver atom is actually interaction of this magnetic field to the electron. This is the first reason we can say. And second reason, that silver atom is a heavy metal, so it is not easily ionized. So why we have taken this particular atom, but hence even if we are taking practically the silver atom, but actually what we are seeing, we are just observing the behavior of electron. Now we know that electron has some magnetic field, and that magnetic field will, sorry, magnetic moment, electron has magnetic moment, and that magnetic moment will couple with this magnetic field, and it will get us some torque. And what will happen after this torque? The electron will deflect it in one particular side. And the higher the outermost orbit has S cell, so for S cell, the L is equal to 0. Orbital angular momentum is 0. You know that all this configuration for S cell, L is equal to 1, P cell, sorry, L is equal to 0, P, L is equal to 1. So you have L is equal to 1 means how many possible state can be possible? 2L plus 1, that is 2 into 0 plus 1 must be one number of a state we can expect. So what is our expectation? Our expectation is very simple. We expect electron will either, we will find electron either this side or this side, and either this side or this side, and hence electrons, we have n number of electrons, and every electrons have different orientation of magnetic moment. So this magnetic field produce a different torque on different electrons. So what we want that this will come into this side, but we have very broad kind of distribution, because some electron will come here, some electron will come here, some electron will come here, some electron will come here. So what we have expected the broad line, not a very sharp line. This is all about classical argument due to torque. And second thing, that if this magnetic field will interact with the angular momentum, then obviously it should be only one. It should be either in this side or this side of this particular screen. So this is our expectation. But what we have get entirely different thing. We have get a very sharp peak, and that is actually symmetric about, this is very sharp peak, and we have get exactly symmetric about this particular Z axis. We have get this kind of situation. So it's a very different situation from the classical argument. Not a broad peak. So if it is not a broad peak, then surely it is not a coupling, or it is not due to torque of this magnetic moment and this magnetic moment, interaction of magnetic moment and this particular magnetic field. There is not only one spot, means L is equal to 0 is not working there actually. Because if L is equal to 0, there must be only one state of the electron. We have two states. And now we have just tried to understand, okay, it may be due to polarization that electron can be spin about its own axis. So it can be spin in either clockwise axis or anti-clockwise axis. So we have two different states. So why we have given it a different name, and that name is what? Spin angular momentum. But this is not only the thing that will be give a surprise. The surprise thing was entirely different. So let's first try to give you what are these two things. So what we have, so we have just give the new operator S, and we have how many state? So due to this S, we have 2S plus one number of possible state is there, just like 2L plus one number of orbital angular momentum. And we have actually two number of state. So I can have a small s is equal to half. So we have a new angular momentum, and that is known as a spin angular momentum. And here spin angular momentum, the small s is equal to half. So if a small s is equal to half, there are two possible directions. and that possible direction can be written as ms is equal to half and minus half. So what we have done, we have said that this state is nothing but half and minus half, and this state is nothing but half and half, and we just try to figure it out what will be the algebra behind all these two states. So we have named it as a spin angular momentum. This is named as spin angular momentum. So if you have any doubt, you can just ask me. Then I will go for next level of discussion of Stern-Gerlach experiment. So this is our expectation. This is our expectation, but this is our result. So you have to always remember this is expectation. And this is result. Are you getting this thing?
Yes, sir.
Okay. So now let's go to do some experiment on this particular thing, and we just try to give, try to explain this, that this is some kind of polarization, that due to rotation of or due to spinning of electrons, the magnetic moment is polarized either in z plus z direction or minus z direction. We just want to say this thing. And yes, but further result will surprise more than this. So what we will do, this whole thing, this whole setup, we will write with, we will represent with a box, and that box will be, let's say, Z component box of SGZ component box. Okay, SGZ component. So if I will change the direction of magnetic field, that this nature will be changed. So let's see what will happen when we will change the direction, and what we expected and which kind of situation will be there. And we have just right now to this, we can say this direction is polarized either in plus or minus direction, plus Z or minus Z direction.
सर जब हमारे पार्टिकल की स्पिन दोनों प्लस में है सर, पीक में सर दोनों में कोई चेंज नहीं होगा, एक प्लस माइनस?
पीक में चेंज होने का मतलब नहीं समझा मैं। ये तो डिस्ट्रीब्यूशन है, ये तो डिस्ट्रीब्यूशन है। डिस्ट्रीब्यूशन का मतलब समझ रहे हो क्या कह रहा हूं? सपोज आप टॉस करते हो, सपोज मैंने आपको 100 कॉइन दिया, ठीक है, और 100 कॉइन को आप टॉस कर रहे हो, और हेड वाले को यहां रख रहे हो, टेल वाले को यहां रख रहे हो, ठीक है। सो आपने पहला कॉइन को टॉस किया, हेड आ गया, आपने कहां रखा? यहां रख दिया। दूसरे कॉइन को टॉस किया, मान लो फिर से हेड आ गया, फिर से यहां रख दिया। तीसरे कॉइन को टॉस किया, फिर क्या गया? टेल आ गया, आपने यहां रख दिया। तो इस तरह से 50 कॉइन आपके यहां आ गया, 50 कॉइन आपके यहां आ गया। उसी तरह से you can just take the 100 number of electrons because you have electron beam. So what will happen? 50% electron will be here and 50% electron will be here. ठीक है?
Yes sir, thank you sir.
So this is repeating of experiment again and again. Okay, then only you can get the distribution pattern. एक इलेक्ट्रॉन से तो एक ही स्पॉट मिलेगा, है ना? बट या तो आप ये करो, या तो आप क्या कर सकते हो, सेम इलेक्ट्रॉन को बार बार फेंक सकते हो, देन यू विल गेट दिस स्पॉट। ओके
सर, ये प्रोबेबिलिटी डेंसिटी तरह है कुछ ये?
बिल्कुल बिल्कुल, ये डिस्ट्रीब्यूशन है, मैंने कहा ना, दिस इज डिस्ट्रीब्यूशन। प्रोबेबिलिटी डेंसिटी ने, दिस इज डिस्ट्रीब्यूशन, नंबर्स बेसिकली। लेकिन वो नंबर्स को हम स्टेट के थ्रू दिखाने की कोशिश, नंबर को नहीं, मतलब आपके पास दो ही जगह मिल रहे हैं, आइदर यहां पर मिल रहे हैं या फिर यहां मिल रहे हैं। So you have 50% chance that getting this state or 50% chance you are getting this state. How you will calculate the chance? Can you give me? मैं अगर आपसे कहूं कि आपके एग्जाम को क्वालिफाई करने का चांस क्या है, हाउ यू विल कैलकुलेट इट बिफोर गिविंग द एग्जाम?
1/2 सर।
हाँ, नहीं नहीं, हाउ यू विल गिव मी चांस दैट कि आपका चांस अच्छा है या खराब है, हाउ यू विल गिव मी दिस चांस?
नंबर सर।
आप क्या करोगे, टेस्ट देना शुरू करोगे। एक बार टेस्ट दोगे, 2 बार टेस्ट दोगे, 3 बार टेस्ट दोगे, 4 बार टेस्ट दोगे, डिफरेंट डिफरेंट टाइप्स के टेस्ट दोगे। When you will give the different types of test, and if you have more than 50%, then you have fair chance to give the good in the examination. This is the only way to predict the something, isn't it?
यस।
इसके अलावा और कोई चांस नहीं है। ऐसा थोड़ी आपको मैं देखकर, आपका चेहरा देखकर बता दूंगा आपका हो जाएगा। राइट? सो उसी तरह से एक इलेक्ट्रॉन अगर आ रहा है, आप इसको गलत ढंग से समझ रहे हो। सपोज दिस इज योर magnetic field and one electron is passed. Suppose one electron will pass. Okay, so एक इलेक्ट्रॉन आया, आप क्या एक्सपेक्ट कर रहे हो? आप एक्सपेक्ट कर रहे थे कि यहीं पर आकर के जाएगा, you will spot it here. Okay, it come here, but when second electron come, you also think okay, it will be come not exactly here, but it will come nearby there. And so why, if I will again and again I am doing the experiment, what is your expectation? It will remain in this region only, in only one region, and you have this kind of distribution. This is a very fair distribution. But what do you expect? This is your expectation due to classical region, but actually you have find that electron will either sharply come at this point or this point, 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 or this point. So how many spot you have? Only 2 spot. So electron will have either in this state or in this state. I am just talking about very sharp picture. It is broad, means electron can be dispersed from here to here. So dispersion is very broad here. Okay, so electron will be sharply there. Why it is there? Nobody knows. Before this, giving the consideration of a spin. So why we have given 2 state of a spin. Okay, are you getting this thing?
यस सर।
यस सर।
Huh. Now, what we are going to do, we will just take the SG, and this is in the Z direction polarized, and this is electron come into this particular black box. What we get? We will get 2 outcome, and let's say this outcome is half and minus half, and this outcome is half and half. And yes, this is intensity I naught, then it has intensity I naught by 2. What is meaning of intensity I naught by 2? Meaning of intensity, that number of electron will be just divided. If you are sending 100, 100 will be there, 100 will be there. What we have done, we have just blocked this thing. We have just blocked this thing. And we just try to allow this particular another state in another black box. And let's say this black box is also in Z direction, What I will get? I will get exactly 50% intensity from the initial level. So I will get exactly same thing because it is blocked. I will get exactly same thing. So what will happen? This will be half and half. So this will be something half and half. But next step is very surprising. Again, I will take the SG. But right now, I will put in X direction. What is our expectation? What is your expectation?
Zero.
The expectation is 0 because this is polarized into Z direction and I have give the magnetic field into X direction. So obviously nothing should be go outside this box. But surprisingly, what you will get? You will get again two state. And this is two state has intensity is exactly I by 4, I naught by 4, I naught by 4. But these two are superposition of half, half plus half, half, and this will be superposition of half, half minus half. Sorry, half, half, half minus half, half, half minus minus half. And yes, you can take this thing as 1 by root 2. मैं करके भी दिखाऊंगा. You will take that thing as 1 by root 2. And you have this kind of superposition. So how this is happening, nobody knows. Only from the quantum mechanics, you can explain this phenomena. But classically, you can all with the help of polarization, you cannot explain this phenomena. Because X direction is totally independent to Z direction. So how you can just make a component of this in the real sense? But yes, in the Hilbert space, this type thing can be possible, and you will see that I will get exactly this thing. Means the eigenvector of Sx can be written in in a basis of eigenvector of Sz. We will just try to figure it out how we can get all this stuff. Are you understanding this thing? Then I will do this mathematics. First I have given you result, then I will prove it. Don't worry. And I have also explained this thing in my first class. Remember?
Yes, sir.
So let's try to do this algebra of angular momentum. So in first part, we will just do the algebra, and second part, we will just do the calculation. For the spin part, only 2 cross 2 matrix is there. So there is not any tough calculation. You have very simple level of calculation. So let's try to go for mathematics behind all this thing. So what we will do, we will just try to define operator, S square operator, and next we have S and MS as a kit. S will take part for the magnitude and MS will take part for the direction. So S square MS will be S into S plus 1 H ket square S MS and SZ S MS will be MS H ket S MS. And what is value of MS? The value of MS between minus S to plus S. And the value of S for ourselves is for half. So MS can be possible minus half and half. So we are saying electron is spin half particle. So we are saying electron is spin half particle because we have also proved that there are two states possible, and this is small s. So small s must be half from this logic. And yes, this all thing due to internal symmetry, internal rotational symmetry of electron, not due to external rotational symmetry or orbital angular momentum. So spin will be part of this. And we have also defined S plus operator, that will be Sx plus ISY, and S plus will operate on SMS, same as last class, nothing different. That will be S plus 1 minus MS plus 1, H cut, and you will get S MS plus 1. And yes, S plus S and S will be always 0. So this is your S plus operator. Similarly, we can define S minus operator, and then we will try to get it on the, for basically a spin half particle. So ms is equal to half and minus half. So you have S minus is equal to Sx minus Isy. So S minus will operate on SMS, and that will be give you S plus 1 minus MS minus 1, H cut, and you have S MS minus 1, and you can put S minus SMS, sorry, S and minus S is equal to 0. So this is the all algebra. Do you able to see this thing? So this will be S plus 1 minus MS minus 1, H cut, S MS minus 1. Okay. So if you have any doubt, there is not any doubt. I'm just repeating the same thing. I'm just repeating all this thing same. But main thing is that we have to give this this number, and after giving this number, we will just try to write each and everything in a matrix, and then we will try to understand what is going to happen. It's okay?
Yes, sir.
Okay. So let's go for spin half particle.
Sir, these S plus and S minus are spin operators, sir.
S plus और S minus operator को क्या बोल रहा हूँ?
Spin operator.
Spin
I
operator.
meant to calculate spin.
नहीं समझा नहीं ये मैं. Spin operator तो S है, S square. S square is a spin operator. S plus and S minus is nothing, but it will raise one state or lower one state. That's it. We will discuss what is S plus, S minus, L plus, L minus. उसको एक साथ discuss कर लेंगे. So don't worry about this. They are known as ladder operator. Spin operator is S square and for the magnitude, and Sz for the direction of Z component. Now, so what we have, S square will operate on half and half. What you will get? You will get 3 upon 4 H square half and half. S square will operate half minus half. What you will get? 3 by 4
0.
H cut to square half minus half. Sz will operate half and half. That will be H cut by 2 half and half. SZ will operate half and minus half. That is minus h cut by 2, half minus half. Okay. So this is very, and please, we are doing this thing analogically from the angular momentum, because rotation is rotation. Either you will do angular momentum or you will do spin. So there is not any difference for the this type of. But what is going to difference? The difference is basically quantum number, where L is equal to 0, 1, 2, 3, but here S is equal to half, and M can be from 0 plus minus 1 plus minus 2 plus minus 3, but here ms is whatever I have chosen is plus half and minus half. So quantum number is going to change, but basically the physics is exactly same. But yes, mathematically this is going to change. And now let's go for S plus half and half will be obviously 0, and you have S minus half, sorry, S plus half and minus half is equal to, you can just put the value of half, half plus 1 minus minus half minus half plus 1 h cut, and this will be go to one state ahead, half and half. Sorry, this will be just go one state ahead. What will be this number? This number will be, I think, 1. Just you can check it. Is that this number is 1? You can easily check. This number will be 3 by 4 minus you have 1 by 4. Sorry, plus 1 by 4. That will be, isn't it? That will be h cut. Similarly, what we have, s minus half and half is equal to h cut. I am just writing directly. That will be half minus half, and s minus half and minus half is equal to 0. And now what we will do, we will just try to write all this thing in a matrix form, because for a spin angular momentum, the matrix form is the most important. So obviously, last class I have done, what will be S square operator in a matrix form? Can anybody tell me? What will be S square operator in a matrix form? You will just get 3 upon 4 h cut square 0 0 3 upon 4 h cut square. So this is your S square operator, diagonal matrix. What will be SZ matrix? You have h cut by 2 0 0 minus h cut by 2. You can easily figure it out. And in which basis we are talking about this? We are talking about half and half and half and minus half. Let's try to calculate what will be S plus matrix in basis of half and half and minus half. Obviously you have 2 cross 2 matrix. So similarly here also we have half and half and minus half. So S plus will operate on half and half, 0. S plus will operate half and minus half. Look at here. S plus will operate half and minus half is nothing but h cut half and half. So half and half will just go for the 0, and again you have 0. So what will be S plus operator? S plus operator is equal to 0, h cut 0, 0. And similarly, S minus operator, you have 0, 0, h cut 0. But I am interested into Sx and Sy. How we will get Sx and Sy? What is Sx? How you will get Sx? Sx
plus S minus
S
S
plus
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 S
S
minus by
minus by
2.
2.
So this will be very interesting operator. You will have something like h cut by 2, 0, 1, 1, 0. And what will be S minus operator? S minus operator is S plus minus S minus by 2i, isn't it? And this will be, again you can have h cut by 2, 0, minus I 0. So this is all, sorry, sy operator. This will be sy operator. So you have all sx, sy, sz operator. So up to this, if you have any doubt, you can just ask me. Then we will see what is sx, sy, sz operator, what will be eigenvalue and eigenvector, and whatever I have proved in the last frame, we will see how the eigenvector of sx can be written in a basis of eigenvector of s square and sz. So you have to remember all this algebra. Only this frame is important for your examination point of view.
सर यहाँ पे ये समझ नहीं आ रहा, जैसे हमने लास्ट
समझ
लाइन जो सबसे लास्ट लाइन है इसी साइड में, लेफ्ट हैंड साइड में, s माइनस इंटू माइन जो हमारा ऑपरेटर है, उसके बाद h कट इंटू, सर अंदर माइनस कैसे पहुंच गया सर?
कहाँ पहुंच गया ये इस पर ऑपरेट करके?
ये सर अंदर
अरे
ब्रैकेट में।
भाई कल की क्लास पढ़े हो? कल की क्लास पढ़े थे क्लास में?
यस सर।
और यहाँ पर मैंने अभी तो तुरंत बताया था एस माइनस ऑपरेटर का मतलब क्या है यार, पढ़ के नहीं आते हो, ये दिक्कत वाली बात है ना। ये इसको क्या करेगा जरा बताओ। बिना पढ़े हुए आना क्लास के अंदर वो सबसे बड़ा सिन है। एक बार नोट तो देख करके आ जाओ।
यस सर, हो गया सर।
हाँ
हो गया सर, थैंक यू सर।
भाई एक स्टेट नीचे नहीं करेगा, अगर -1 करोगे तो कहाँ आएगा, -12 पर ही तो आएगा।
ओके सर, हो गया।
कल की क्लास में भी किया
सर।
था, कल की क्लास में पूरी की पूरी यही किया था हमने, नहीं किया था?
यस सर।
देखो मैं कोई भी ऐसी चीज नहीं बताता जो डायरेक्ट आ जाए आपके पास, वो या तो पहले किया हुआ रहेगा या तो फिर मैं करूंगा। सो प्लीज आप इस चीज पर ध्यान रखो, है ना। S माइनस इज डिफाइंड सच दैट इट विल गिव यू 1, तो इस पर हाफ पर -1 करेंगे तो -12 ही तो आएगा। ओके चलो, सो लेट्स गो फॉर what are these matrix and what is the eigenvalue, and we will identify किसे हम half और half minus half कह रहे हैं। Let's try to figure it out. So this is not needed. I am writing each and everything again, and let's try to figure it out what we are doing and why we need two different quantum number. Also you can have different sense. What is s square operator? This will be 3 upon 4 h cut to square 1 0 0 1. What is sx operator? Sx operator is, or first I will write sz operator. Sz operator h cut by 2 1 0 0 minus 1. What is sx operator? Is h cut by 2 0 1 1 0. What is sy operator? Is h cut by 2 0 minus I 0. Now look at here. So what will be the eigenvalue of s square? So I am writing it in this side. What will be the eigenvalue of s square? Can anybody tell me? What is the eigenvalue of s square?
3 by 4
Eigenvalue of s square is 3 by 4 h cut square. But what are the eigenvector corresponding to this? Is 1 0 and 0 1. Because this is diagonal matrix, you can easily write the eigenvector is 1 0 and 0 1. Now my question is that, suppose this is my one vector, let's say phi 1 vector, and let's say my another vector, let's say phi 2 vector. So if I will ask you, this eigenvector you will find from phi 1 or phi 2, can you explain me from this eigenvalue is associated with which vector? Just give me answer. That this 3 by 4 h cut square is associated with 1 0 or 0 1. Because at a time, this will be associated with one particular vector, isn't it? So here, due to degeneracy, they are doubly degenerate. So why they are making the 2 cross 2 this thing? So hence they are degenerate, doubly degenerate. We cannot say this number or this eigenvalue will associated whether 1 0 or 0 1. So this is the one of the toughest challenge. But what will happen if I will get another operator Sz and I will find the eigenvalue of Sz, then what is the eigenvalue of it? That will be h cut by 2 and minus h cut by 2. And what will be the eigenvector? Then eigenvector for h cut by 2 is 1 0. Eigenvector of h cut by 2 is 0 1. Minus h cut by 2 is 0 1. And for Sz, you can easily say that this h cut by 2 is associated to 1 0 and this minus h cut by 2 is associated to 0 1.
0 1.
So here is not any problem. You can easily recognize what is the eigenvalue and what is the corresponding eigenvector. But here you have problem. This is for s square. You have problem. But if I will combine these two, and what I will say 3 by 4 h cut square and half and 3 by 4 h cut square and minus half. Which eigenvector is associated with 3 by 4 h cut square and half? Then what you will say? 1 0.
1 0.
100. And what we will say 3 by 4 h cut square and minus half? Then you will easily say 0 1. So this is not enough to make a complete basis. This is not enough to make a complete basis. We need one more operator, and this operator is a beautiful part is that s square and sz is going to commute. So if these two are going to commute, they can be simultaneously measurable. And beautiful part is that even they can be simultaneously measurable and they have common eigenvectors. And due to this sz, we can easily say this is my eigenvector corresponds to 3 by 4 h cut square and half, and this is my eigenvector corresponds to 3 by 4 h cut square minus half, and we can easily make a complete basis. Complete basis means we can recognize which vector is associated with what, with which measurement. So why we need two basically quantum number in spin also as well as in angular momentum algebra also mathematically. And best part is that in this basis 1 0 and 0 1, these two are diagonalized, and this 1 0 is actually identified as half and half, and this 1 0 is identified as half and minus half. इस 1 0 को क्या कहते हैं? Half half. 0 1 को क्या कहते हैं? Half and minus half. If sz is defined like this. And now, can you tell me what will be eigenvector of sz? Eigenvalue of sz? Sorry, sx. Let's talk about sx. What is eigenvector? Eigenvalue of sx for sx?
Plus minus h cut by 2.
Very
Sir,
good.
plus minus.
Plus h cut by 2 and
Minus h cut by 2.
minus h cut by 2. Agreed? जैसे कल बताया था मैंने कि Lx का आइगन वैल्यू देखना 0 1 -1 आएगा, बताया था ना in last
Yes,
class.
sir.
Same thing is here also. But eigenvector for h cut by 2 you can find that will be 1 by root 2 1 1 and this will be 1 by root 2, 1 minus 1. Isn't it? And now what you can do, this thing 1 by root 2, 1, 1, and let's say this is phi 1 or phi plus कर देते हैं, and this will be phi minus. And this 1 by root 2, 1, 1 is actually, I can write this 1 by root 2, 1, 0 plus 1 by root 2, 0, 1. Isn't it? So what I can do, I can write phi plus as written in a basis of 1 by root 2 up plus 1 by root 2 up and down. Isn't it? We can written in a basis of up and up down. And what will be probability that you will get h cut by 2? Or what will be probability that this phi plus is in up direction?
1 by 2.
1 by 2. What will be probability that phi plus is in up down direction? 1 by 2. And look at the Stern-Gerlach experiment. If you remember this thing, I have just make that particular thing that this will be your Sx, and this is, let's say, up. This is your up, and you can phi plus as well as phi minus here, isn't it? So what you can do, you can write up also in a basis of this thing. This is your up, you have written in phi plus and phi minus. You can easily write 1, 0 is a basis of 1 by root 2 phi plus 1 by root 2 phi minus. You can convert this thing also. So hence you can written in a basis of phi plus and phi minus. What will be, I will ask you, what will be probability that up will be in phi plus? What will be answer? 1 by 2. Isn't it? If I will ask you, what will be probability, and this is nothing but up and up. What will be probability that up in phi plus state? What will be answer?
1 by 2.
1 by 2. So if this has probability I by, so this has intensity I by 2, it must be half of this. So this will be I naught by 4, because probability is just half, isn't it? And similarly, this will be also I naught by 4. Intensity will be just going to decrease due to this number. You can easily write this thing. 1, 0 can be written as half. You can easily write this thing. 1, 0 can be written 1 by root 2, 1 by root 2, 1, 1, plus 1 by root 2, 1 by root 2, 1 minus 1. You can written, this is phi plus, this is phi minus. Can you write this thing or not? So you can see this is a typically quantum mechanical treatment. This is a typically quantum mechanical treatment. Same thing you can do for SY also. So each and every step we can discuss. You remember we have done this thing? Just last part of SX, or last part of, you can say that Stern-Gerlach in X direction. This will be your plus part is there. So we have finally explained where is the problem, that if you are changing that Z to X, there is not 0 intensity. There is some value of intensity, and we have calculated from this quantum mechanics. Okay. Okay. So this is the first level of your spin algebra, and then we will. So कब तक है first class आपकी?
7:20.
7:20. Okay. So we will take a break. I think 7:20 is over. Yes. We will take a break and we will just go for the next level. and we will just discuss poly spin matrices, and then we will try to do some problems. Okay.
सर ब्रेक कितनी देर का होगा?
5-7 मिनट. कितना देर चाहिए ब्रेक? आधे घंटे?
नो सर, बस नॉर्मली ऐसे ही पूछ रही थी.
हाँ, बस जस्ट मुझे बोर्ड क्लीन करना होता है ना, सो भाई, अदरवाइज काफी डर्टी हो जाता है.
ओके सर.